Example 6 can be a bit of a problem, and the issue really is this plus here and here. Because geometric growth is to do with multiplication, division, and having that plus in there makes the mathematics a little bit awkward. Okay, so let's first of all set this up. And instead of using T3, T4, T5, T6, we're just going to use T3 in terms of A. So where T3 is AR squared. Okay, we don't know A or R, but those are the terms that we need to know. Plus T4 is AR cubed, and that's going to be equal to 12. Okay, so I'm just going to maybe highlight that. T cubed is that, and T4 is that term there. And then we need to do the same thing over here. We'll write T5 and T4, T5 and T6, and we'll write them in terms of A. So I'm just going to call this equation 1 because we have a two variables, so we're really going to have a system of equations here. So equation 2, we're going to write this as AR4 plus AR5 equals 48. Okay, and that's going to be those two terms. I'm just going to highlight them so that we can keep tracking a little bit better. And we need to solve this system. Now, this is a problem because we need to cancel out A's or R's, and this plus can be an issue. However, if you recognize that this is factorable, and we factor this, I end up with AR squared times 1 plus R equals 12. And here I end up with AR4 times 1 plus R is equal to 48. That plus ends up in a factor with R, and we can get rid of that factor with division. And this is a nice thing now is I can write this now in terms of a fraction. I'm going to put equation 2 divided by equation 1. So it's going to be AR to the power of 4, 1 plus R, and that's going to be equal to 48. That's going to be my numerator. And I'm going to put in the denominator AR squared, 1 plus R, and the denominator is going to be equal to 12. Okay, so in this case here, I've set this up as a ratio because now I can cancel out the 1 plus R terms, and I can simplify that fraction. The A's cancel out as well. Okay, so the A's cancel out. I can simplify the R expression, so this becomes R squared is equal to 4. And this allows me to solve for R as plus minus 2. Okay, so once I've done solve for R, I can substitute this back in. So when R is equal to 2, I'm plugging into one of these equations. And I'm going to solve for A, so A R to the power of 4. I'm just plugging into this equation above. So it's going to be 1 plus 2 equals 48. Solving for A is going to be equal to, in this case, we're going to end up with A times 48 equals 48, so A is equal to 1. So when R is equal to 2, A is equal to 1. That's one set of solutions here. Okay, and then when R is equal to negative 2, I'm going to plug that into the same equation. So A negative 2 to the power of 4, 1 minus 2 equals 48. Okay, so this ends up being 16 times negative 1, so that's negative 16 equals 48. A then is equal to negative 3, so when R is equal to negative 2, A is equal to negative 3. So that's my other solution. Okay, so there we go.